Okay, hello world. Today I'll be talking about my project where I'll be controlling the Turtlebot tree using cloud data. So for my project, I will divide it into three parts. The first part is the IoT setup. The second part would be the Turtlebot tree setup. And the last part would be the combination of both first and second part. So the first part will actually require me to set up the IoT, which I'll be using Adafruit.io. So this first part is basically to control a circuit, which will be shown here, to be controlled from the Adafruit IO platform, which will trigger the LED to light up and switch off accordingly. So to do so, I'll show you both the Adafruit.io platform and the IDE that I'll be using to code this first part. The first thing you need to do is to create an account with Adafruit.io. Once that is done, you'll need to come to this feed section where you'll be creating a new feed. As you can see, I've created a new feed called new feed. But to do this, I'll just show you to create a new feed. Just type new feed and create. So you have a new feed, something like this. And the next thing you'll do is to create a dashboard. So I've also created a dashboard. Simply what you need to do is just create new dashboard and you can name it whatever you want. So new dashboard and create. So what I've done for my project is to create 4 different feeds called blue, green, red, yellow ID. And I've created a dashboard, which is called the Turtlebot tree IoT. So when you create your new dashboard, you wouldn't see anything. But for my project, this is what I've done. I created 4 blocks to toggle the 4 individual feeds. So to do so, you just need to go to the newly created dashboard and create a new block. Select the toggle feed and select the feed that you'll be using. So I'll be using the new feed for this example. And you can name this block whatever you want. So I'll just call it toggle feed. And yeah, so what I've done for my project is to leave the text as on, value as 1, text for off as off, and value would be 0. And just create a block. So this is how you create the dashboard, which I'll be using to control the LEDs on my circuit. Once you have done these blocks, you can head over to the IDE. So I'm using Tony IDE with the Raspberry Pi Pico W. And this is the MicroPython code that I've created. So I just imported some of the necessary libraries and dependencies. I have labeled the LEDs accordingly. So I'll be using 0, 1, 2, 3, and they are set to output. I've also put in this part where you can choose to connect to your wireless connection. So the SSID and password. Since I'll be using MQTT, this is necessary to connect to Adafruit.io. So you can just change the username and the key, which can be found here. So this is the username and the key that you'll be using specifically to your account. And I created 4 feed IDs. So these names can be anything you want. Just make sure it's easily identifiable. And the feed ID would be the blocks that the feeds that you actually created. So for example, this yellow LED feed is called yellow LED feed. And similarly, red LED, green, and blue accordingly. So it has to be specific to the feed that you've created. Next, I've created the connect Wi-Fi code. You can find this anywhere online, but it just connects to the Wi-Fi. And once it's connected to the Wi-Fi that you input here, it will show that it's connecting, and once it's connected, it will show which SSID it was connected to. If not, it will just exit the code. So you call the connect Wi-Fi, and then this is the code to connect to the MQTT server. So you just try to connect to the MQTT server. If it's connected, you'll just print that it's connected. Else, you will just exit the program. Furthermore, I also included this function to reconnect if there's any disconnective issues. For example, inactivity, or there's a drop in the connection with the MQTT server. This code would solve that issue. So next would be to define the location of the feeds. So again, this is not specific, but I have created this line to define the location of the feed. So for the yellow feed, this is the username, which is labeled as shown here, and the toggle feed ID, which will be identified here. So if it wants to access to these, you'll actually go to the individual location of the feed. And then this callback function will just will subscribe to the platform and check what data it's receiving and from which feed. So if the message is 0, which is off, it will actually toggle the individual LED to switch off the LED. If the message received is 1, it will toggle the respective LED to switch on the LED. So this part is basically calling the function and connecting to the feeds here. And this function will just continuously loop to check any message. And I set a sleep of 1 second so that it does not run continuously, but it will just take a break for 1 second. And if there's any error for the MQTT server, it will break the loop. And if it's any other error, it will also break the loop. So I'll show you how this would work. Okay, so just make sure that you have connected your microcontroller. So I've connected the Raspberry Pi Pico W, and I'll save this code. Give me a moment. Okay, so once you have connected your controller, you can save the code and run it. So you can see in the shell. So it's connected to my Wi-Fi and connected to the server. What I need to do over here is go to the dashboard. And okay, so now I'll toggle the respective LED and you should see it light up. Okay, let me just bring this up. So if I toggle the yellow LED, it will send a message here. And it shows that it's going to, the message that's received is 1. And it will toggle the LED value to 1, which turns on the LED. And switch it off. You will receive 0, which will toggle off the LED. And I can do this with any other LED. So there we go. So this is the end of the first part of the project. I'll be showing you the second part of the project. Okay, so for the second part of the project, I'll be showing you how I control the Turtlebot tree and the scripts that I'll be using to implement for the third part. So for the second part, what we'll need to do is actually connect to the Turtlebot tree. So what I'll be doing is just to run these few steps. I'll run ROS core, and I will SSH into my Turtlebot tree to gain connection. So just writing the IP address for my Turtlebot. Oh, sorry, it's the wrong one. So while that is loading, I'll be showing you the script that I'll be controlling the Turtlebot. So the script that I've created is I have the script to move the Turtlebot to the first point, and then a script to return back from the point. So I'll show you this script. And I'll show you the script to return from. And lastly, the script to combine everything. Okay, so that's about it. Okay, so I've connected to my Turtlebot. So what I'm going to do is just launch it. And I will split this. So I'll just show you the explanation of my code, and then I will demonstrate how it works. So in this code, you can see that, wait, let me see. Let me just change this. This. And it should work. Okay, great. So the first thing would be this code, which is to move it to a certain point. So I have point A, B, C, D, and what you'll be doing is it'll move forward a certain distance and you'll turn left. So the main code is just basically to move the Turtlebot by a certain distance, turn left by 90 degrees, and then move forward by a bit, and then you'll exit out of this code. And for the return, it's similar to how it moves forward. It will move back, it will rotate left by 90 degrees, and then it will move forward. So it's a reverse action of what it did in the previous part. So once you reach back to the start point, it will just turn 180 degrees. I did not write a code to turn it 180. So I just used the turn left function and do it twice. And it should face back at the origin in the correct orientation. And then you exit the code. Right. So to demo this, I will be running these two codes. And let's see. So the Turtlebot tree is now connected. I will need to run the individual codes. So let me just see. You can see that all the 4 codes are here. And I'll do the same for the return. And here are the 4 codes to return it. So I'll just demonstrate since it's already connected. I will run the individual code. So the first demo will be to move it to point A. And then the next code after it's done with that is to return from point A. Okay, so this is a demonstration of the Turtlebot moving to point A. So now it's at point A. I'll be executing the return from point A code. Okay, so now you can see that that is the simple process of how the Turtlebot will be moving from start to point. I'll be showing you the other points that I've coded. It's very similar, just that the difference would be in the values, which is altered differently based on the parameters. Here, let me just close this and I'll show you everything. So move to point A, it moves by this amount of distance. Point B is closer, so it moves lesser. Point C is actually similar to point A, but I've tweaked it differently because it's not exactly the same based on printing the points on the piece of paper. So I edited it accordingly. And then point D and point B is also similar. So instead of turning left for point B, you will turn right for point D. And then for the return from, show you. So that was the code that I demonstrated, which was return from point A. Return from point A is to move back, turn left, then move forward, and then it rotates 180. It's similar to point C. And yep, I have altered the distance. And point B, similar, instead of turning left with point D, it turns right. And the distance is also specific for my demonstration. Right? So now let me just close this. I'll show you point B. And return from point B. Okay, that is basically the end of the second part. So now I'll be showing you the third part, which is to combine all the part 1 and part 2 together, where I'll be controlling the Turtlebot tree using the data that is received from Adafruit.io. So to do that, I'll just exit from this. And I'll be connecting to this script. And I'll show you what's in this script. So this is the script that will combine both of the part 1 and part 2. So what will happen is that I'll connect to the Adafruit.io client, and then it'll create a node. And in this node, it will be called the Adafruit_io_publisher. And it will publish these topics, point A, B, C, D. And what I've also done is I've set 3 variables, which is start position, end position, and current position. This is to actually troubleshoot some of the issues that I faced previously. So once the program runs, the Turtlebot will be at start position. So I set it to true. And because it's not at the end position yet, I set it to false. And for the current position will be declared later. I set it as none for now. So what it's going to do is, while the code is not shut down, it will actually take the data from the feed, which is yellow LED, red LED, green LED, and blue LED. It will take the value and then it will publish it to the data. It will take this data A and publish it to the topic ABCD. So based on this initial checks of these variables, if it's at starting position, which will be the case, it will read this line first. And once I send the data from the feed, it will send a 1 value. So whichever LED turns on, it will go to it will take the respective actions. So given, for example, if it takes data from A, which is the yellow LED, if the current position is equals to A, it will continue. But because it isn't, the current position is set to none, it will take the action of opening this move to point A script, which is the one that I demonstrated here. Okay, so it'll move to point A. So now that it's moving, it will set the start position to false, and it will set the end position to true. Furthermore, it will set the current position, since it's moving to point A, it will set it to A. So once this is done, you can see that these variables are based on this data that was received, and it will move to the next line, which is if end position is true. So end position is now set to true, and if I toggle off the LED, you'll receive a data value of 0. And because for this example, the current position is at A. So if it's currently at A, or if since I put it as not as A, it will run this action, which is to return from point A. So to return from point A is this line of code. And because it's returning, it's going to return back to the start position. So it's set back to true. It's no longer its end position. I set it to false. And the current position is no longer true. So it's back to the default. So this is an example for A. It will work for any of the other points, A, B, C, D, yellow, red, green, blue. And for other cases where if the end position is not true, and if the data is 0, basically these two functions is to say that if it's not at the end, and if it receives a data value of 0, it won't do anything. And likewise, if it's at the start position, but it receives a data of 0, it will not do anything. So this will be the loop that it will be running, and I will demonstrate the process of how it works. Okay, so let me just close this. Before I connect this, I'll just show you what is going to happen from the previous part. Okay, so I'll show you this screen, just like this. Okay, so what's happening, to show everything, I'll connect this MicroPython script, and to test, I'll show you the yellow LED. So it's connected, and now I will connect to Adafruit.io Python code. So when I enter this, it's connected, and I will show you what happens on this end. So now that it's connected, I will send it to each of the points. So this is for yellow. Okay, so now I'll return it back. Okay, now I'll show you maybe the green. And then I'll return it back. Okay, Now I'll fast forward the remaining process for red and then return it back for blue. Okay, so that's the end of my project demonstration. I've showed the first part where I set up the IoT, where it will toggle the LEDs from the Adafruit.io platform. And then in the second part, I've shown you how the Python scripts control the Turtlebot, which moves from start to any of the subsequent points. And then in the third part, which is to combine both parts together, where it will subscribe to the Adafruit.io and take whatever data that is receiving from there and move the Turtlebot tree to its respective location and back. So that's the end of the demonstration. Thank you.